Okay, kind of picking up where we left off. We were, I guess, kind of working with displacement. So we're using distance calculations or the angle or the basic like a radial angle, and we make waves out of that or waves out of the distance. And then we started doing a thing where we could displace certain parts of the image based like a distance and an angle type of displacement. I guess you'd call it like a polar coordinate displacement or something. But anyway, we were just kind of working with this code. But I think I want to do something a little different this time. I'm going to add in just a call here, and we'll just, it's like a random number generator thing. These quick random, quick hash, these are just a way of creating a like a repeatable way of getting the same random numbers, like a deterministic random number. So you can kind of, as long as you feed it the same seeds, you'll get the same random numbers out. And hash is a little different than actually getting kind of the random number, but these are just rough, like they're kind of crappy algorithms as far as quality randomness is concerned, but they're fast. It's just like getting some digits of sign and like truncating off leading digits, and just some mathematical thing that tends to be kind of random, but it's really quick to calculate. Because some other random number generators, they kind of do a lot more loops of like kind of hashing up the data to make it more random. So these ones are a little quicker when you're calculating millions of them for all the pixels on the screen. So anyway, we're just going to call this, and we can feed it an arbitrary number of double, floating point values. So maybe what we'll do here is we'll kind of we'll kind of redo some of this stuff. Let's create. I'm not going to cover the background of like what we're doing here exactly with the code, because it's just this library that I've written, and I'll probably do some stuff in the future more in depth on that. But we're going to create it's essentially something that maps from two-dimensional points to a double value, which is kind of why I have this P2D abbreviation. And so the point gets passed in, and we do something with that value. Well, I'm going to get the drand, that's just what we called it, I guess, for double random or whatever, of p dot x and p dot y. And we'll get that value, then we'll tell the helper to save that value, and we'll just call it rand. I'll call it random. That's fine. We don't need to abbreviate everything quite that much, right? So anyway, run that. And let's see, what do we get? We get this, which I'm not sure how well that compresses, but it's basically lots of pixels of randomness. Looks pretty random to me. That's not too useful because, I mean, it just looks like static. It's not as useful as if I could kind of have more like a random contour or shape rather than individual pixels. So there's a little bit of a trick that I can do, something I've added to the library. It's excuse me, it's we take the input and hang on, maybe not the input. So this integer interpolate. So if I do integer interpolate alias, and just call that, I think I know what's going to happen here, but I'll go through and show you. Let's see. Okay, looking at what's coming out of there, it still looks like random. And the reason that is we did not do the center scaling on our context. So we will run that again. And now you will see not that, but that is what comes out. And it's like, okay, what's going on here? Well, integer interpolate is basically saying the input, let's take the input and round it to the nearest integer. And so what we end up seeing in this image is that this area here is all like x is 0 and y is 0 or something, and whoops, and then x is 0 and y is -1 or whatever. I mean, it's basically just taking those numbers and rounding them. And so instead of it going through and actually getting a unique value for every point, it's kind of rounding them down so they kind of get the same value, and therefore they get the same random number assigned to them. Now, the interpolate is kind of misleading here, because interpolate alias, well, that just means interpolate it and not really do any real interpolation. Interpolate linear gives us linear interpolation. And so let me load it up. And so now we have those same values of those pixels, but this is a linear interpolation. So it kind of fades from what the value was at this point to the value at this point, or going up here. It'll essentially adjust that value. It'll kind of draw a line between the two values and smoothly transition over to that. So, I mean, I guess I could, I could draw it on here. I mean, it's kind of ramping up the value from one to another, or if it's going down, it's going to ramp it down. And so then if the value changes direction, you'll end up with it's like kind of smoothly going between the values like that. Whereas the aliased version would just jump up, jump down, and kind of like set the values to whatever they were across the entire width of that area. There's a few more types of interpolation that are in here. I think cubic is one of them. And cubic tries to do more of a smoothing. So, sorry, I have to reload the image. And this one, it doesn't do like a line between them. So like the line would go up and down and up like that. The cubic tries to kind of smooth it out and kind of draw a spline, or it takes more pixels into account and tries to like smoothly blend between them. That's why it kind of looks more smooth without like lines. Kind of, you can't really tell where the big giant pixel boundaries are. I'm going to take this and scale it a little bit though. So like let's take the let's scale the input to like a tenth of the size, because those are some huge pixels. Okay, and so now here is a cubic interpolation, and you can kind of tell that it's a grid of pixels, but it smooths them out pretty good. And I'll flip back to linear just so you can kind of get a feel for what that would look like. And so here's linear interpolation. Kind of gets this a little bit of a starburst pattern, like these bright areas in here. They kind of get a little bit of a four-sided star shape or whatever. And so it definitely looks a lot better to do the cubic interpolation. So I think I'll just kind of keep doing cubic. So that's an interesting tool, I guess. The idea that we can kind of generate these random blobs gives us kind of an interesting ability. We create the random, and then let's get back something we had before. I think, let's do the distance thing. So we did distance, and then we adjusted the output. Sorry, I'm going to type it again. We did a sine wave of the output, and I think we made it a little higher frequency. So get that, and we'll save it out, and we need to center that. And we'll call that drip. Let's run that. Okay, so we have this thing, and actually you can't see it, but there's actually like these darker regions are, that's like going into negative numbers there, because the sine wave normally does that, but we can kind of deal with that. I mean, we could bring it back up. We could do this to move it into a region between 0 and 1. So we'll just correct that real quick, and now you can see there's not quite such strong dark regions. It kind of dips down to 0 and comes back up to 1. Okay, so we got the drip. I'm going to turn up the frequency a little bit on that, just so that we can kind of have a little bit more detail in there. So now we're up to that. And then last time we worked with displacing stuff. So I'm going to just take the same drip, and it equals drip, but this time the input is displaced. And we're going to displace it by random. And the random is the distance that we're going to use. And the angle, let's see. Let's just do a common. The angle is, let's just do an angle of 0. So let's just see what happens when we start displacing stuff by a random amount. It's just easier to put these things together and see what happens. Okay. So that drip was displaced by a random amount. Now, there's a little bit of a pattern in there, but it looks like things are pretty crazy. So I think what I'm going to do is I'm going to take that random amount, and the output is just probably too huge. So let's just turn down the volume essentially. So scale the output down to like 1/10 of what it was, and we'll just see what that displacement looks like. And okay, now we can see some stuff. Now what's going on here, and we kind of saw this before, is since the angle is 0, it doesn't really displace in the y direction, only in the x direction. But it still just kind of like added some randomness to this, a little bit of turbulence almost. And so we should maybe see what we could do. Well, here's an idea. Let's just keep experimenting, and let's actually let's drive the angle with random, and we'll set the displacement to be always 1. So I don't know what we're going to get out of this. It'll probably be messy looking garbage, but we'll see. And here it is. Whoa. Okay, so I can kind of see a little bit of a pattern there, but yeah, again, things are turned up way too high. So I could always just take 1 and say scale that output to 0.1, because I mean 1 is just like a constant 1 throughout the whole thing. And we'll see what we end up with. Flipping back, let's load it up. Okay, so the distance is 0.1 that's being displaced, and the angle is that random value. And then you can see a little bit more of the waves. I'm going to actually turn the distance down even more. Let's do 0.02 or something like that. That's pretty low, so I would think that we'll get, yeah, it's kind of interesting. Definitely looks more like turbulence or smoke or something like that than just displacing a random distance, random angles. Kind of interesting. We can mess around with the scale of these. So let's say we bring this back up a little bit, but then we scale the angle down. Let's do 0.1 on that so that the angle doesn't vary as much. Just playing around, kind of seeing what we can come up with. See what that, if it looks like anything interesting. Not really. I think we'll leave the angle random. Let me run that again so we can like remember where we're at. what the image looks like. It's this, which looks like some pretty crazy stuff. But instead of adjusting the output, let's take that random and just make it bigger. Like, so the input, that's that kind of the XY size of it. Let's scale the input up to like, let's do like 5 times bigger, because I think the details are so small. It kind of doesn't look that interesting. And now we got something kind of weird. So that we're figuring out how to better use the displace, I guess, to make some interesting weirdness. The randomness, like this randomness, was that smaller size, but if you turn these into bigger pixels, you can kind of get a little bit more of the effect we're looking for. So anyway, I think that's enough coverage right now of how to do some displacement with random. And so we've added another tool to our toolbox, being able to add randomness into this. So thank you very much for watching, and we'll hopefully make some even cooler stuff next time.